I'm going to do is review a few concepts related to object creation and constructors, overloading and overriding, and copy constructors and deconstructors. This is all again in preparation for the final. You'll actually have to do some of this stuff on the final. I'm going to have you, as I mentioned yesterday, create a base class, and then I'm going to have you create a derived class, and you'll have to overload a few things. So you might want to consider the use of the constructor in terms of its overloading. So if I have a base class and I have data inside of the base class, then I can accept and I can change the data inside of the base class, and each class should keep track of its own data. I keep mentioning the concept of passing arguments, or actually it's really identified two different ways. Some people call it overloading the constructors. Some people call it passing. Like as the slide says, there's passing arguments to base class constructors. That's overloading. So to overload something, you're going to, or to call something, I guess technically constructors aren't really overloaded. Well, I guess you could do it. So if I have a, let me talk about an example. If I have a shape, this is I'll just use the example I just gave you a few minutes ago. If I have a shape and the shape has a name, so I'm allowed to set a name on my shape. My base class is called shape, whether it be abstract or not, it's just shape. And in there I have string name. So then I decide I'm going to create and derive a class from shape. I'm going to call it rectangle. And the rectangle is going to have a height, a width, and a name, because I want to give all of my shapes a name so I know what they are. So then when I create a constructor for the base class, I'm going to have a constructor that has the same name as my class shape. It's going to be shape, and then the parameter of shape is going to be string name. So I can have shape without any parameters. If I only have one variable, I'm going to have two choices. One with no parameters. The other one is going to take in a string name. And then I'm going to say this dot name is going to be equal to name, or whatever it is I'm taking in from my parameter. So then I decide, well, okay, so I'm going to have a derived class that's built on top of shape, uses shape. So now I want a constructor that's going to take in, I can have a default constructor, doesn't take on anything. And then I'm going to have one that takes an X, a Y, or an H or a W, H, a W, and a name. So my constructor is going to look like my regular old constructor, but I have this name that's come through. And the biggest deal now is to figure out, well, what am I going to do with this name? We actually have two choices. We can overload that constructor by doing something like this, to say this would be shape as an example. Shape name, which means I'm specifying on the constructor line. This is a constructor, by the way. It's for square. It's in the class square. The constructor is called square. Square takes on an integer side. So I put a colon at the end of that, and this just happened to word wrap onto two lines. And then I'm calling the constructor from shape, or in this case rectangle, and it would be shape string name. So I'm explicitly calling, which means I'm overriding this constructor to use the shape name as well. So I'm taking shape name, adding a height and a width to it over here. That's probably the most efficient way of doing it, because when you create the derived class for rectangle, it's first going to create a shape. So actually this part runs first. So whatever you put next to, this is the constructor line that you're implementing, and this is the implementation file, by the way. You do colon, shape, string name. You're going to have a shape before you get a rectangle. If you send the name back, that you're saying call that constructor. In the base class, the shape name constructor, not the default one, but the shape name constructor will invoke, and it'll set the name to the name you gave it. And then it'll go, okay, now I want to create a rectangle. I just created my shape, and now I'm going to do my rectangle. My rectangle has my height and my width. So set the height and width on the rectangle. Then it's all done. That's the most streamlined way of doing it, the most industry standard. That's what professionals do. What amateurs do, or what people do that don't know how to overload a constructor, will create two objects. Actually, some people do this with the classes anyway because they don't understand constructors. Just create the object, use a default constructor, set the name to unknown, set the height and the width to 0, and then they run a set method. So if I did this in my constructor for my name, for my rectangle, I wouldn't be overloading I'm not overloading constructors at this point. If I just make a constructor, it says rectangle, H, W, and name, or N for name. And then inside, I set this H and this Y, W, or whatever to the height and the width. And then I got this name to deal with, so I can go, okay, set name. So then I run set name, name. In that scenario, I've created the base class, I've created the derived class, and then I went back and changed the base class. Why create it and then go back and change it? More work, doesn't run as fast, runs slower. That's one piece of variable, that's one name. What if you had like 1,000 of those things, or you had like a couple of those things, more than one? Depending upon what you're setting, what you're changing, why set it just so you can go back and change it later? It's easier just to, when you create the object, pass the information to it, set it when you create it, instead of having to go back and set it. It's almost like if I say, okay, I'm gonna do something, and then you do something with the intention of changing it. It's like, okay, I'm gonna fill out this exam. So the first thing I'm gonna do is read all the questions, and then I'm gonna answer. Then I'm gonna put my name on it. Then I'm gonna do that. You're just doing it in an odd order. It makes more sense logically to, if you're gonna create the object, create it correctly the first time. Once it's created the first time correctly. It's kind of like when you say, okay, I'm going to paint the wall. So before I paint the wall blue, I'm going to paint yellow, green, and red first. Then I'm going to paint it blue. And you're looking at the logic going, well, why did I do that when I could just paint it blue? Which is what you're doing with those constructors. So if you just create the object and make it blue, then you don't have to change it back from all the other things that it went through before you decided, okay, now I'm going to change it to this. It's faster to just paint it blue if you're going to paint it blue. So anyway, long story short, that's why you want to overload the constructors. Because when you're creating the objects, just create it correctly the first time. Then you don't have to go back and set this and get that and set this and do this to it. A lot faster. So then there's this philosophy people do, and they say, well, all right, so if I'm going to create a constructor, am I just running those setters and getters? Technically, if you have a constructor and it's calling a setter, it's 2 method calls, not 1. Why do it twice? So then there's a whole breed of people that would say, and then that you'll see more variance out in the real world, because if you're going to create the setters and the getters, some people put the set and the get calls from the same object creation instance. They'll put them in the constructor. So because they don't want to rewrite the code, that's okay if you want to do it that way. There's a whole train of people think that's perfectly fine. And there's another breed of people that say, well, then you're running multiple method calls when you don't really just need to call one method. Each one of the method calls is a new stack entry. It takes more time. The object will actually get created faster if you just set it right there instead of calling a method. Because then you're not taking up as much memory, you're not bouncing around as many times throughout the source code. You're just setting it right there. Plus, in the future, you might change the set name or the set height or the set width function that you created. And then you're going to create a change in your constructor behavior because you changed something outside of it. So what if you said, well, I'm going to change these squares or this rectangle. I'm creating a rectangle. So I'm going to change my rectangle so I can't have a rectangle that's smaller than 5 by 5 for this application. And then you change the set so it does a check to make sure that the height and the width are not smaller than 5 of something, 5 integer values or something. That eliminates the ability for you to create a rectangle that's smaller than 5 in another scenario used a year from now in another program. You've now made it so that your rectangle has to be 5 by 5 because your constructor is calling the set height, the set width, and doing those checks to make sure it's larger than 5. So now you've limited and you've restricted the use of that object and the constructors. So if you just had the constructor take whatever you had as the height, whatever you had as the width, assign it to its data members like it's supposed to do, without calling any other method, then you're ensuring that you're actually assigning the data correctly. The data gets assigned. Then you can add the rules on top of that for this application over here that requires a 5 by 5 one. And then you can have one over here that requires a 10 by 10 one. And over here is a 15 by 15 or something. But your constructors are always the same for all 3 of those applications, and you haven't had to go back and change the set name, change all the behavior around just to make the object created correctly. Anyway, so it's more convoluted, it's harder to understand if you make the constructors call other methods. So a lot of people say, no, constructor should never call another method. Constructor should just construct the object. So then that's where that school of thought comes from, because if the constructor is just constructing the object and it's not enforcing any rules or anything, it's not giving you your whole business logic. You build your business logic out into your setters and your getters. You put the protection on that, then you can do a check. So if in that other case, if I made a rectangle and I made it 2 by 2 and the application said it needed to be 5 by 5, then the program would come back and say, hey, you know what, we tried to use your rectangle, it's a 2 by 2. You know, you need to create, I'm actually talking about a square now. we created a rectangle, or let's just call this a square now. Your square is 2 by 2. Your program requires a 5 by 5. Would you like to change it? And then you have a method that says change rectangle to 5 by 5. Because you created one but 2 by 2. But your constructor created it. So your constructor shouldn't limit your ability to create the object. It should just create the object for you. All those business rules about what you want to do with that object, you can add later down the road. You know, so it's like trying to be a student and if you think about it, if you're a student and you have your constructor, so it does registration and does everything else for you. That means you can't just be a student, you have to register in order to be a student. And then all of a sudden you have all these business rules that are being imposed on the objects because you can't create the object unless you have a class code. Well, I haven't picked a major yet. I haven't picked a class yet. Well, then we can't make you. We can't put you in the system. We can't create your object. Why can't you just create me as a student? So if you're going to limit your object creation behavior, you're going to limit your object creation behavior by enforcing the rules in your setters and your getters. Long story short, just make the constructor a self-contained way that just constructs the object. Makes a student regardless of whether or not they have a class or something. So make a rectangle regardless what size it is. Just make the rectangle. And then if you're going to make the rectangle, don't play around with setting all the information from a derived class that was already set in a base class. It's like painting the wall blue. You know, it's like painting the wall green before you paint it blue. Just paint it blue. So anyway. Alright, so enough of that. If you want to pass arguments to constructors, you do it like this. You put a colon in here and you call the base class constructor that you want to use. And you can send the parameters in, which is actually kind of interesting because if you look at the concept here, we're taking in the side. And we're taking in the side from the derived class constructor. And we're going to pass that derived class information to the base class. Can we please keep the volume down in the back? You could take the conversation outside if you'd like. Thank you. I just don't want to feel like yelling over you. So you take the information in on the derived class constructor. You take those arguments in. A lot of people don't want to do that. They're like, I don't want to take in a name because I'm a rectangle and I have a height and width. They don't want to ask for the name. It's like then they go, oh, well, why don't you want to ask for the name? When it's a rectangle and you want to set the height, the width, and the name. Well, rectangle only does height and width. So then I've seen people do this. I've seen them make an object of a rectangle, then they make an object, or they make an object of the shape, and then they try to use the shape in the rectangle. It's like, no. If you create a rectangle, or a square or whatever, you get a shape. You get them both together. And so if you're going to call and you're going to make an instance of the derived class, then give it all the information it needs, and then send it back. Send it back through the constructors. Which is actually kind of interesting theory in terms of how that works. And it works the same way in all object-oriented languages. So you should always overload constructors. Same concept works. Alright, so here we have just some examples here of selecting multiple base classes. If you do this, and this base class doesn't exist, the compiler will give you an error. If you don't specify, this is the interesting thing with C++, if you don't specify a base class constructor, it will use the default constructor. If the default constructor does not exist, you get an error message. It does not know how to construct. You're explicitly calling on a derived class a base constructor, and there's no default constructor. Even if it's empty, you're going to get an error message. The class can't be created without the constructor. Alright, so passing information back, passing this back into the base. Those are the parameters that belong to the base. We can also redefine base class functions. So I want to talk a little bit, refresh your memory on overloading and, did you have a question? Overriding, yeah.
The rectangle and the shape
Yeah.
assignment that we did yesterday.
Yeah.
I did create a base class constructor for the shape, a default constructor, but I still used it to override the derived class constructor. I couldn't complain.
If you're not calling anything outside of a derived, it should work just fine. Excuse me, outside of a default. Were you calling a constructor in the derived that took on parameters?
Yeah.
You were?
Yeah.
Yeah, it's supposed to complain. It's supposed to. But then again, you guys were the ones that were using the arrows instead of the dots, so I don't know what compiler you're working with, but it's not so standard. Theoretically, it's supposed to complain. If it doesn't complain, you guys got lucky. Your compiler is creating it for you, or thinking of the logic ahead of time. It's usually compilation error. It's not really a runtime error. The running of the program should work just fine. But it's, long story short, if you don't have a constructor, it's not supposed to be able to construct the object. If you're going to run a constructor, it's going to look for a base class constructor. If it doesn't have one, it's going to use the default. If you don't have a default, it doesn't know what to do. In theory, if you go out in the real world and you start making classes and you don't put any constructors in there, people are going to look at you funny. Just the same way as if you don't know how to override from a derived class, you don't know how to use a base class constructor. They're going to go, where did you learn C++? Because that's what you're supposed to do. So it makes things more streamlined, makes things easier. Now, if you don't document anything, people go, oh yeah, cool, I like you. Because no one likes to document, but everyone likes to create constructors. Anyway, in practice, put a default constructor in anyway. Just even if you don't think, even if you're not getting an error message, you want a default constructor. You don't necessarily. In fact, if you work with Eclipse these days, you just press a button and it goes create. Actually, does this for Java. I think I have never tried it in C++, but I think it should be consistent. Little button that says, give me my setters and getters, give me my constructors, give me everything. Because everyone does it, it's now a menu option. You just select it. It'll just do it for you. There's no excuses why you can't do it. So, I mean, unless you're writing it manually using Notepad or something, or Dev actually. Dev, you know, somebody was showing me code blocks the other day. You might try code blocks. I don't know if it works on what operating systems it works on, but it's on my to-do list to go try it out. I might exchange that with Dev. Dev is a little old. Dev C++, Bloodshed compiler, a little dated. I know I've been using that. I know I used it for the first 2 weekends of this course. But you might find some quirks with it. So it's kind of outdated a little bit. So I might actually update myself to code blocks. So, but we'll see. I haven't fully explored code blocks yet, but everyone keeps telling me it's good. So. All right, so if we're not working with constructors, we're working with methods. We don't want to override data unless we really have to. But for the most part, we do want to overload and override methods. So we can redefine a base class function. If we do that, we're redefining the function. The function is a derived class that has the same name and the same parameter list as the base class. If we have, in terms of redefinition, this is overwriting. If we have a base class that says set sides, and it takes on 2 sides, a height and a width or something, and then in the rectangle we make a new method, it says set sides, and it takes on 2 parameters, a height and width, and it's the same signature, we've redefined it or we've overwritten it. If we change the signature slightly and say set size, same name, and the signature is height, width, and the name, now we have 2. As long as it's just slightly different and different in the parameter list, then we can run it 2 different ways. The same thing that's true with overloading constructors. So some people say, well, you overload a constructor when you have multiple constructors and they all take on different parameter lists. As an example, what if I want to create a rectangle with a height, comma, width, and then I have one that says width, comma, height, and then I have another one that says height, comma, width, comma, name, and then I got name, comma, width, comma, height, and I got name, comma, height, comma, width. I got like all these different constructors. They're all legal. They're all the same. They're all overloaded. So that's another definition of overloading. When you overload methods or overload constructors, you have the same constructor, same name, different order, different number, different settings with those parameters. It's overloaded. If it matches identically to something else, if it's within the same class, you'll get an error message. If I have two constructors that take on the height and the width, they both say, you know, rectangle, height, width, rectangle, height, width, compiler come back at redefinition, because technically you have redefined. You can't do it within the same class. If I have a base class that says set sides and it says a height and width, and derived class I have set sides and it has a height and width, well, now I have one for the base and now I have one that was redefined for the derived. So I can change the behavior, because some things between the base and the derived change. And that would be like the set, and going back to my example, those rectangles or squares only being 5 by 5. Well, I can set everything correctly, and then in my restricted rectangle derived class, I can have the set so it doesn't allow it to be bigger than 5 by 5. But my base will allow it to be anything. But my derived class that comes from that, this is the restricted square, limits the height and width to 5. So if I try to set it higher than 5, it's the restricted one. Oh, I can't do it. It has to be, excuse me, if I set it lower than 5 by 5, it'll come back and say, no, sorry, you have to make one that's at least 5 by 5. So then I can override, redefine the behavior. So you want to overload the functionality instead of restricting your base class. There's a lot of people would say, okay, I'm not going to build a hierarchy, I'm just going to build one rectangle, and the rectangle has to be 5 by 5. Not very flexible. So if you build a base class that just represents the concept of the rectangle, and then you have a derived class that says 5 by 5. You have another one that's 10 by 10, the other one's 20 by 20. You have more flexibility, you have more objects, but and a little bit more work creating that hierarchy. But you have a lot more flexibility. If you ever want just a generic one, you got the rectangle right there. And then you got the 5 by 5 one if you want that one. So anyway, it replaces. Typically used to replace the functions in the base class with different actions in the derived class if we redefine it or override it. In terms of overriding, we can also overload. So overriding is not the same as overloading. Overloading means we have more than one version of the same function available to us. So with overloading, parameter list must be different but the same name. So objects of the base class use the base class version of the function, and then objects of the derived class use the derived class version of the function. So, and a word of difference with that virtual. With abstract classes and the use of virtual, we aren't overloading and we aren't overriding at all. Not overloading and overriding. We're implementing. It's implementing. So pure virtual doesn't exist. How can you overload or overwrite something that doesn't exist? So you're delaying the implementation until you get the right object behavior. That makes sure you don't get any wrong object behavior. If you're overloading and you're overriding, you have the ability to have wrong object behavior. I might get stuck in a case in which I got this square that's stuck with 5 by 5 because I'm using a derived class method that got overloaded or overwritten, and then now I'm stuck with this thing and I'm going, not as flexible. So virtual actually gives you more flexibility because until the derived class object is created, it doesn't really exist. So I don't have any base class functionality that's going to happen by default because there's nothing there. It's not implemented. Because you can't make instances of abstract classes, they don't exist. But you can make instances of derived classes from abstract classes, they do exist. And in that particular case, you're going to delay the execution until the end. Because then you don't want all those multiple versions that could accidentally be used. So we got our base class, we got our derived class. We did inheritance a lot. Here's a problem with redefining. Let's look at this, considering we have a base class that defines an x and a y. And then x calls y. So we have functions x and y, and x calls y. Another problem associated with methods that call other methods as well. And then we have a class called derived. So we have base class, and the base class has functions x and y, and x calls y. Then we have a derived class that inherits base class and redefines y. X calls Y from the base. We redefined Y. An object D of class derived class is created, and the function X is called. When X is called, which Y is going to be used? The one derived in the base class or the redefined one in the derived class? Well, let's take a look here. Here's what the problem looks like actually. We have a base class, we have X and Y, and we have a derived class that has Y that was redefined. So object D invokes function X in the base class. Function X invokes function Y in the base class, not function Y in the derived class, because it's from the X class. X was never overridden, just Y. So X is from the base class, is going to call the Y from the base class, not from the derived class. Because the function calls are bound at compile time, and this is what's called static binding. Virtual creates dynamic binding, so we can get both. We can get the overridden Y with a virtual method, actually. We can't get it on static binding because the base only knows about the base, the derived only knows about the derived when it's originally bound. So if this X is going to call this Y, it's going to call this Y, regardless of what you've done with Y. Which is actually kind of interesting. So anyway, let's just look at polymorphism for a second as well. So polymorphism and virtual method functions. The virtual method functions, we saw that in assignment number 4. If you did the in-class exercise, or maybe you're doing it today, finishing it up. Those things aren't really due till 3 o'clock today. I'm going to give you time this afternoon to work on it very shortly. So the function in the base class that expects a redefinition in the derived class, we know that already. So we say that it's virtual, void Y. We can fix the problem. The problem we just looked at here, we can take the static binding and turn it into dynamic binding by making Y a virtual method. So it supports dynamic binding. So the functions are bound at runtime to the function that they call. So without virtual methods, C++ uses static. You put virtual in there, and now we're using dynamic binding. So at runtime, we're going to bind it. So if we do that, we get whatever happens at the beginning of the current. If it's a derived class instance, we're getting the derived class Y. That's going to be used with the X instead of the base class X. I don't believe I have any questions on the final in regards to static versus dynamic binding, but not a bad concept to be familiar with because it carries over into multiple different languages as well. So polymorphism requires references or pointers. It's the ability of an object, okay, polymorphism in the language can be implemented a couple different ways. When we create the instance of the objects, we can have polymorphic instances created. As an example, I just discussed polymorphism with those overloading of the constructors. We have a shape that can be made in 3 or 4 different ways. Or a square or a rectangle can be, that's polymorphic. We can make one with height, one with a width, one with a name, no name. So it's the ability of the object to react to different invocations or different situations. So a polymorphic object itself could be like a print object that says print. Well, C in and C out are polymorphic objects actually. They print anything. C out a float, an integer, a double, a string, just C's it out. So we can overload that operation to create more behaviors. So we're overloading it because it's still going to print out a float, a double, but it's not going to print out a point instead because that's what we want it to print out. So that's what's meant by objects being polymorphic. We also have polymorphic methods where we have the same name, but we have different signatures for the method. So it's like get something, and then it can get something with this, this, and this, or it can just get something with nothing, or it can get something with. So we have different versions of the same method. It also creates polymorphic. So sometimes it's associated with the ability of the object to respond to different inputs, or it's the ability of the methods to respond to different calls. So sometimes they also refer to it with virtual methods, because and that's why it's mentioned in this chapter actually, is because it creates, the virtual creates true polymorphic behavior. So if it really is a square, it is a square. It's not getting any shape stuff. It's just a square. But then the same shape could also be a rectangle. And then you also have the ability to take the shape that's a rectangle and a square and treat them both like shapes. So the object hierarchy is also polymorphic, because if we're a shape and we're anything else in the hierarchy, we're always a shape. So we can morph back into a shape. So we can change different forms, and they usually refer to that. In C++, they call it upcasting, where we can go up through the hierarchy, which is actually the exact opposite of what that sounds like. So if we have 3 levels in the hierarchy, we're a shape, we're a rectangle, and then we're a square as an example. If we're a square, we can go up, which I think is backwards. I think it's down. We can go up from a square, we can go up to a rectangle, and from a rectangle we can go up to an object, because the highest level is the object, but it's the lowest level of abstraction. So I never really got that, because I always turn it upside down, and I put the object on the bottom, and I build everything up from it. Well, everybody else puts the object on the top, and they build everything down from it, and then they go up, which is why it's called upcasting. They go up to the object. They go down to the root. Anyway, but however you think about it, that's what it's basically referring to. That's also polymorphic behavior in the language. So C++ supports polymorphism in many different ways, actually. Oh, let's see. The redefining versus the overriding. Redefining functions are statically bound, and overridden functions are dynamically bound. So we redefine without virtual, we override with virtual. So virtual functions is overridden, and a non-virtual function is a redefinition. Seriously, I don't think anyone really thinks of it this way. I mean, technically that is the case. I like to use the word overriding and redefining all in the same word, all mean the same thing. And it's commonly referred to as the same thing, but there is a difference in C++. Other languages, there's no difference. Other languages don't support this static versus dynamic binding. If you take Java as an example, everything's virtual, but you never use the word virtual. But it's all dynamic, and it's all overriding. They don't even introduce the word redefining. So C++ has this redefine concept because we have static binding. So we have static binding, we're going to say, oh, everything without virtual is redefining, everything with virtual is overriding. Okay. And then you get past C++ and you learn another language. And then you go, oh, well, there's no such thing as redefining over. It's all overriding. Is it overriding, overloading, or redefining? Anyway. And then people get confused. Like, are we talking about replacing it, or are we talking about complementing it, or adding to it? If you don't want to, there's only one way of getting rid of it is to replace it. If you replace it, if you redefined it, or you've, oh my God, what's the other word? I've already confused myself. Overridden it. So it's overloading versus everything else. Overloading, it doesn't mean defining it, and it doesn't mean getting rid of it either. It means loading it up, overloading it. So it's like when you take a potato and you stuff it full of stuff, it's still a potato, but it's full of stuff. It's overloaded. So it's loaded. I only got that because I was looking at a Carl's Jr. ad like about a year ago, and they said overloaded potatoes. So I got my, I was on a radio commercial, and I went, overloaded potatoes? Automatically I'm thinking, overloaded potatoes? And then they says, load them up and then overload them. So their definition of overloading was to take the potato, you stick it on a, you stick the potato in this little bowl thing, and it's overloaded because the loading of the potato extends past the potato and turns into a bowl of whatever it is you put in there, and then there's a potato on the bottom. It's overloaded. Which means you stuff so much stuff in there, it's occupying more than just the potato now, so it's like the whole bowl is the stuff. Long story short, it was the grossest thing I've ever seen. Although I did go in and try one. You know, they put little bacon bits in there, and it would gross out any vegetarian, but it's like a potato, but it's not a potato anymore. It's like the unhealthiest thing on earth as well. I put sour cream in there, but just, we're getting close to lunch. I can talk about food. Virtual destructors. So it's a good idea to make a destructor virtual if the class could ever become a base class. Well, we'll see. Otherwise, the compiler will perform a static binding on the destructor in the case that it is ever derived from one. So, Abstract class versus pure virtual functions. We know pure virtual has the equals 0. If you did assignment number, the exercise number 4, that made more sense too, probably. Indicates that it's pure. That means you have no function definition in the base class at all. So pure virtual function is a function that must be overridden versus one that should be overridden. So it contains at least one pure. Abstract class contains at least one pure virtual function by nature, by definition. So an abstract base class is a class that can have no objects. We know that, I hope. It serves as a basis for derived classes and may or may not have objects from a derived class. You may not actually have any classes till you get way up the hierarchy. Class becomes an abstract class when you have one or more pure virtual functions in there. So you have a pure virtual function, it gives you an abstract class. All you need is one, which is different than Java, because Java, you have an interface where you have no implementations, and then you have abstract classes where you can have some implementations and some not. In C++, we just have, we could make an interface by having an abstract class that doesn't have any implementations in it, and then we've made an interface. But in order to make it a truly interface, we have to go pure everything. So we must implement everything. So we can actually mimic a true Java interface using pure virtual methods inside of an abstract class in C++. So multiple inheritance. We support multiple inheritance. You just string them with a comma. Can't do this in Java. In Java, you have one class that extends another class. That's it. And then it implements as many interfaces as you want. But we don't have interfaces in C++, so instead we take an interface, we turn it into an abstract class by putting all virtual methods in there. So then we can extend this class and that class and that class and that class and that class. So C++ supports multiple inheritance. Java supports single line inheritance. Big difference between the two languages. And we support it by just going comma, 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 comma. We just list out as many classes as we want in there. So this is public class cube, and cube is a square and also a solid rectangle, because we did public square, comma, public solid rectangle. When we define the derived class, we inherited two classes from that. So yes, you can declare a derived class that inherits more than one base class. What happens with that? Well, then you have an object-oriented language that's not safe either, reliable. What if I took a boat and inherited a car, an airplane, and a submarine from it, or into it? And I'm like, well, it kind of changes it. It's like taking a human, and a human is inherited from a dog, a mouse, and a pigeon. And you're like, what? That's a human? So you can break the hierarchies. You can actually have some interesting some nonsense objects that just don't make any sense. So again, it makes the language a little bit unreliable in that sense. Plus, you don't have any interfaces by concept. So unless you make it pure virtual, you're not going to have any requirement that that method actually ever gets implemented. And if you don't have the requirement in, there's no law that says you have to do that. Plus, there's no tagging. There's no required tagging. So in Java, you can do what's called tagging objects, where you make an object part of a hierarchy by implementing its interface, and the interface is nothing more than an ID that says, hey, I'm part of this grouping. Can't do that in a roundabout way. In a roundabout way, you can do that in C++, but it's a little bit easier, more straightforward using that interface in Java. Anyway, in Java, you'd actually have to create a base class and tag the base class. In fact, that's kind of interesting. You can make a base class printable or print, and include that base class in everything that you're doing, and then you've tagged every single C++ object as well. So anyway, that one was chapter 15, by the way. I also want to cover a little bit of part of 14, and I want to just kind of talk right through so that we can have kind of a longer, well, I still want to give us a long lunch, but then I can kind of get through all the subject matters, and I'll let you work on those assignments a little bit longer. But So in 14, I'm not going to go through the whole thing. You want to know the difference between static members, and you want to know the difference between a regular instance variable. Static, is a class level variable, and class level is available to all instances as well as the class itself. So we use it by the class. So if we have a counter, you had an assignment, I believe, that used a static member, actually. So if we have like a counter, count all the objects that we have in a class, we're going to use a static data member for that. We just put the keyword static in front of it. C++ also has this thing called an initializer area of the code, not on the final, not heavily used. So I wanted to refresh your memory on friends, because some of you may have missed that lecture in the second or third. No, this is the third, so it would have been the second weekend. I should have mentioned friends, and I think I did. And I mentioned it yesterday, and I got some interesting looks. So I'm like, when I said don't make friends with C++, and people went, I have no idea what that means. So at least walk away from this weekend knowing what that means. That means a friend is a function or a class that is not a member of the class, but has access to the private members of the class. So you don't belong to the class, but you're accessing private data members of the class. So you're either going to make it a friend, or you're going to make the private data members protected. You make them protected, and in some cases you can get at them. If it's a friend, and you make anything a friend, then they can always get at that. So protected is through inheritance. So if one class is inheriting another class, you can make the private data members, you can make them friends. You can make them friends. You can make the private data members protected and not have to deal with friends if one class is inherited by the other class. If the class is totally unrelated, not in the hierarchy, way out in another hierarchy, if you make the method a friend, then the friend method can access the private data members of the original class without being a member of that class. That's dangerous, which is why you don't make friends. Yeah? In C++, we don't use packages, but in it has to be within the same project scope. So we use the word friend next to it, so we declare it as a friend method. And it's the methods we're declaring as friends because the methods are going to be manipulating data. So in the virtual method, if assignment number 4, I believe it was, I said keep the private data members. If you actually followed, and a couple people were actually smart enough to ask me yesterday, can we make that protected? I said, yep, you can. If you make it protected, you don't have to use friends. If you make that data private, you'll have to use a friend method to access that data. Otherwise, you make that data protected. So there's a big school of people that say make it protected. Don't make, and then inherit one class from the other one. And then if it's protected and you're using inheritance, it works. If it's private, you derive it. You try to implement that area method to change that piece of data called area, and that piece of data is private. You cannot implement that virtual method to change that data. You're going to get an error message. So either you make the method a friend, or you change the data. If you're going to use the data, you're going to change it to a protected data member instead of a private data member. So it's actually kind of interesting. If you do that assignment number 4 and you actually do it the way it's written, you can't unless you make a friend. So, huh? Yep. You can also get a by. I was going to mention that. You caught me. I mean, you got me right before. So anyway, the other way you can do it is what I was going to mention next, and I'll mention it now actually. If you make a private data member and you have public member access to it, then you just run the methods. So if you're going to change the area and you're going to make it private, you can change it to protected to get past it, and then you can actually change the area. Or you can say get area, set area. If you're going to do that, then you're going to make those methods public. If you don't want to do that, you make it a friend. So there's so many other ways of doing it without making it a friend. So that's why people say, well, why do you want to make it a friend? Because you just violate the rules completely. So this was sort of a workaround to make something work when people couldn't figure out another way. And there are some rare cases that you don't want to make it protected, or that you don't want to use a public. Maybe you don't have access to a public data member, but you just want to give it access to that private data. Then you make it a friend. Anyway, a friend method can be a standalone function or member function of another class. So when you overload and override operators, you generally use friends, because if you make it a friend method, then you can have access to it to change the data. So it's declared as a friend and of a class with a friend keyword in the function prototype. Here's an example here. Friend void set a value, friend void some class set number. So you just use the keyword friend. You don't have to program in this on the final, but there's some theory questions on. I think there's at least one question, not too many, just about one question on the friend concept. You can also have the entire class as a friend. So here's class. Friend class, friend class. So you could say, hey friend class, make the whole class a friend. That's kind of dangerous actually. Alright, so we know that we can do member-wise assignment, so we can use the equals to assign one object to another object if they're both the same object type. So we can initialize an object with an object's data. So initialize 2 with 1. So instance 2 is equal to instance 1. And then we can use the initializer here, which just says rectangle R2 is equal to R1, assuming that rectangle R1 is also a rectangle. Alright, in here I'm looking, oh, here it is, this is what I wanted, the copy constructor. For those of you guys who don't remember what the copy constructor looked like, I thought maybe I'd refresh your memory and it might help your understanding of a copy constructor. So it's a special constructor that's used when the newly created object is initialized in the data of another object of the same class. So we say rectangle R1 is equal to rectangle R2, and they're both, and they have data that they're basically holding on to. So the default copy constructor copies it field by field, and it works fine for many situations. So here's the problem. What if the object contains a pointer? So we have class some class, and we have a constructor in here, and the constructor is taking a value which is going to be equal to a new int, and we're following the value and it has equals to a value. So the value in this particular case is a pointer, and it's a new int. And now we have a copy constructor here, so we get using the number-wise copy with the object containing the dynamic memory. So here's that scenario I was trying to give you earlier with the dynamic memory of that copy constructor. So I say some class object 1, some class is just holding on to a dynamically allocated value. It's a pointer value, it's a new int. So then I say some class object 2 is equal to object 1. I created object 1 and I gave it 5. So I created object 1, the value is up here and it says 5 up here originally. And then I said some class object 2 is equal to object 1. So here we go, object 2. And the value is equal to object 1, which means they're both pointing to the same memory address. And then I said object 2 dot set value to 13. Well, it got changed for object 1 as well. It's supposed to be 5 up there for object 1, but it's not. It says 13. That's the problem that you want to use a copy constructor for. This is the line of code that is actually making the copy. This is a member, they call it a member-wise assignment. I just say when one is equal to the other, when you do an assignment expression, it makes a copy of the object, puts it into the other. But the problem is it doesn't, by default, it does value, it doesn't do reference. So it doesn't copy referenced memory. So programmer-defined constructor looks like this. This is the same name as the regular constructor. Looks the same as a constructor. We know what a deconstructor looks like. It has a little tilde in front of it. So that one's identifiable. This one is only identifiable by the parameter. A copy constructor must take a reference to itself. That's what makes it a copy constructor. If you don't put this in here, you've made a constructor. It never gets fired. So this is actually an overloading of the assignment expression, the equals. So there's a lot of people that will go around, going back to the constructors, will go around the concept completely. Say, you know what, this is too difficult, I don't want to write a copy constructor. Instead, I'm going to overload the equals operator. It's about the same amount of work. Actually, probably more work. This is probably easier. So you can overload the operator, the equals operator, to make one object equal to another object. And if you're going to do that, you're going to do this. What are you going to do? You're going to go values are going to be equal. You're just creating another new int. So value is going to be equal to a new int, and then follow the value and have it equal to the object.value. Well, what's the object.value? Well, that's this guy up here that you took in. You use the keyword constant because you don't want to change the original. That's a kind of optional actually, but it's very standard to put that in there. It will work without it. But you want to make sure that you don't change what you're copying accidentally. So you put constant in there, take a reference to what you're copying. So my class, my new class, is going to be equal to a copy of my old class. Take my old class in, this is my old class right here, copy the value. So I say follow the value, take object.value here and have it equal to this. So this is my value, is my new value. So I took up in here, I created a new space for object 2 to point to. I took this guy and I copied it over to object 2 space. So I don't really have a true copy. I have two separate memory locations. In fact, I think this slide will probably show this to us next. Here it is here. So now I have two separate, one's got the 5 from object 1 who didn't change, and now object 2's got 13 on it. So each object now points to a separate dynamic memory. Different locations, this is what they call a deep copy. This is a deep copy. This is a shallow copy. It's shallow because it only copied the reference to the memory, it didn't copy the memory. So deep copy, this is the philosophical thing for today, is not a real copy. A deep copy is a fake copy. A shallow copy is a real copy. But a shallow copy doesn't work for us because when we don't have two values, we only have one value, and we shallowly copied one to the other. So I guess shallow people aren't as good as deep thinkers, deep people. Deep people really have original thought. Shallow people just copy everybody else. They think like everybody else. You know, so that's the philosophy of it, you know. That's why people are called shallow, I think. If you're shallow, it means you have no original thought. You just copy everybody else. You wear what everybody else is wearing. You eat what everybody else is eating. You just go with it. You're shallow. There's nothing to you. There's no substance to you. If you're deep, then, you know, you got some deep thought to you. You got some originality to you. You actually have your own thoughts and opinions. You pick out your own clothes. You eat what you want to eat, kind of thing. You're deep. So you want to be deep. You know, you don't want to be shallow. It's like people. That's actually back in the 80s. People that was really popular. People kept calling each other shallow. You're just shallow. People still use it actually. You know, they criticize each other. You know what? Why don't you just think for yourself? Why are you so shallow? You know, why don't you just understand what I'm trying to tell you and just make your own opinion? Just don't listen to what everybody else is saying, you know. It's funny because it actually works in C++, and that's where it comes from. I mean, in my opinion, that's where it all comes from, is C++. It's all about programming. But, yeah. But anyway, that's what's shallow versus the deep. If you remember, you know, anything with a copy constructor, you just don't want to be shallow. Because then, you know, if this object number 1 changes the value, object number 2 is going to hold on to the same value. You're all going to do the same thing. You're all going to be following the same stuff. You're not going to be thinking for yourself. You're not going to have your own values stored for yourself. So, because you're shallow. All right, so programmer, in terms of the programmer-defined copy constructor, since the copy constructor has a reference to the object it is being copied to, it can modify the object, which is why you're using that keyword constant in there. If you get a copy, you can modify the copy. So there's people that use the keyword constant everywhere. I'm kind of lazy, I don't do it, but there's schools of thought that anywhere ever, they use it with arrays, they use it with objects, you know, you can put it at the end of any method you want. It means you just can't change anything in there. So it's like a safeguard. It says, hey, you're not allowed to change anything in there. So, all right, operator overloading. You don't have to do this on the final exam. There is an assignment actually where you could do it. So you take the operators in the language. I went over this already, but I will just kind of review this. I can't remember if there's any questions, multiple choice questions on this at all. If there was any questions, it'd be multiple choice. So operators are the plus, the minus, the equals, the indirection. So on the C in and the C out, those are operators. So it's an object with an operator that says, give me this, give me that. Well, it's an I stream. I mean, it's an IO stream. So it's an in stream or an out stream. that's coming from that, coming in or coming out of an object, which is what the operator is doing with those symbols. So the name of the function of the operator overloaded function is called operator, because these are operators, which is actually kind of interesting. So you have operator plus, operator minus, operators equal. So this is the name of, and then going back and saying, well, I thought we were doing object-oriented programming. This is really a function or a method. You don't make a whole call for this, you make a function call for this. So what do they look like? They look like this. Here we make void operators equal. So as I was saying before, some people will go around having to make a copy constructor, and then they'll just overload the equals operator. So whenever this object, some class object, is copied to another using the equal, because equals is doing the copy for you, whenever that happens, then overload the operator equals so that it copies the memory for you. So it's a workaround for people who are afraid to create constructors, copy constructors. I don't know why people would be afraid. I think the copy constructor is easier than doing this. You have to write an entire new method or function to overload the operator when you could just add it to the class and it goes with the class wherever the class goes. This doesn't follow the class around unless you stick it in the class, which you can do. And if you stick it outside of the class, you end up having to make it a friend sometimes, depending upon what you're copying, if it's private data. So then you start messing around with the access modifiers as well. To invoke it, you can you have one to invoke the operator, the overloaded operator. We can say operator can invoke a member function by going object1 dot operator is equal to object2. Operators equals. So the difference is we can't explicitly invoke a copy constructor, but we can explicitly invoke an overloaded equals operator. So, but why? What was the difference between object 1 is equal to object 2? If we said object 1 is equal to object 2, we got the copy constructor. If we do this, we get the overloaded operator. Or if we overload the operator and we put it as part of the class, every time we go equals to equals, we're going to get the overloaded version. So, and another side note about when does the copy constructor get invoked, it's more than just the assignment expression for equals. So if we overloaded the equals operator, every time we use the equals symbol with this object type, we get the overloaded behavior. But there's other cases in which the copy constructor invokes without an assignment. Anytime you do pass by value, you get a copy. So if I were to go through all the trouble to overload this operator, I still would be stuck in situations in which I wish I had a copy constructor. And I don't have one because I decided it was too hard. I wanted to overload this operator, which is harder. So then I figure, well, okay, now I'm stuck in a situation where I send my object as a parameter to a function and I pass it by value. And all of a sudden I get a copy of it made over there. And the copy is using the reference, the original reference. I didn't get a real copy. So when you send it by, when you pass the object by value and a shallow copy gets made, you need a copy constructor. Overloaded operator is not going to work. So if I had a choice, I'd make the copy constructor and forget about overloading this equals operator. It only works in one particular case. But then people think about, well, what happens when that case comes up? I'll just overload another operator if that happens, and then I'll overload, and then I'll just change the entire method body over here to make a new piece of memory to actually make a deep copy for me, instead of just having the object, the self-contained object, make its own copies when it gets copied. So it's like the constructors. You can cut down a lot of work, not have to call a bunch of external stuff, just by making the object itself self-contained. The object knows how to make its own copies. The object knows how to instantiate itself. It knows its own rules. So the more knowledgeable, the more intelligent you make the objects, the easier they are to work with. You don't have to have all these workarounds and stuff. So that's the one way of thinking about it. But this is programming, so people can go out of their way to do things the hard way all the time. So anyway, here's what have we got going on here? Anyway, I'm not going to get into the syntax because you don't have to do this for the final, and most people, you can't overload operators in Java. You can overload operators in C++ though. You can't even overload operators. Ooh, can you overload operators in Objective-C? I don't think you can. I think it's restricted, but don't quote me on that. I have to go look that one up. Very few languages, C++ is one of them, but very few languages will allow you to overload those operators. C++ actually has type defines, which is another. It's not overloading anything. It's just, I don't like the way int is spelled. I want to call it INTEGER. So I do type define, int space INTEGR, and then I use the whole spelling of integer I instead of int I. And it works just fine now. And then people look at your code and they go, what in the world language are you using? So you can't do that in Java, but you can do that in C++. And then for the longest time, you couldn't make enumerations in Java. Now Java supports enumerations. Java 5 and above, you can do enumerations. But enumerations are one of those things like, you know, in C++, you go, why do you want to say enumeration colors, red, white, and blue? Because I can't remember 0, 1, and 2. Okay. So for the longest time, people say, well, what do we need enumerations for? That's kind of outdated. And then lo and behold, the Java people figured out, oh, okay, people like enumerations. They keep complaining that they don't exist. We'll just add them to the language. So now Java's got enumerations. Java does not have structures, though. Objective-C has structures. Why they put it in Objective-C, I have no idea. Why in the world do we still use structures? I don't know. Because you can take a C++ structure, or C structure, I should say. It's not even C++. Before we had an object, we had a structure. If you hold up a structure and you put it side by side with a class, the only thing different is the word struct is replaced by class. You can take a struct, turn it into a class by changing the word. The things are the same. It's the identical structure, or the identical component. So if we're working with C++, we're supposed to be using classes, and if we're working with C, we're supposed to be using a struct. And if we're Objective-C, we're using a class. Why in the world support a struct in that? But a struct is from C. It's like legacy. But people still like it. It makes sense because you can combine multiple different pieces of data all into one title. And actually we still have unions. We have unions in Objective-C as well, which is kind of weird. We don't have any of this in Java. Java, you have a class. We don't have any non-object-oriented components in that language. Well, outside of the enumeration now and the well, we have arrays. We have static arrays, but we also have dynamic arrays in Java. So, anyway, long story short, structures, people like them because, I don't know, if you're not going to do any object orientation with them and you just want to combine a bunch of data types and put them all together under one house, like structure person, and person's got a first name, a last name, a date of birth, and all that other stuff, makes sense. And then you use it like a data type. It's not an object. You just use it like a data type. But then a structure actually supports methods. So you could put methods inside of a structure. And then you go through all that trouble. You might as well just cross out the word struct, put the word class on there, and then use it like a class. It's the same thing. So anyway. All right, returning values. The this. We did talk about the this pointer. It is a pointer. So this number. This is a pointer, which is why you guys found it necessary to use that symbol. So. I don't believe we have any of this questions on the exam, but if we did, it's going to be in this context here. Referring to the object self. So it's this. This is a pointer to itself. So actually, when you return from a copy constructor, you're returning yourself out of that. You're taking another object, you're copying it into you, and you're returning yourself out of that. So you return self out of that copy constructor. So where's that copy constructor? It's further up. Operator overloading. Let's go back up here. Well, you don't have to write one for the exam, so don't worry about it. But it's in here. Here it is here. Copy constructor isn't returning anything. Overloaded operator for the equals returns self. That's how this works. Constructors don't normally return, but this automatically returns self. So the implementation of this copy constructor is taking the person information object. So you're always taking a reference to the same object type. You're going to say name is going to be equal to new character. we're going to take the old one and we're going to copy it into the new one, string copy, and then we say the age is going to be equal to the object age. So we just take all the information that's dynamic, copy it to new memory that we've created for our current object, and then this is invoked automatically, is returned automatically, I should say. When we overload some of the, like the equals operator, we're returning ourself. When we overload cout, we're returning a stream that comes out of it. So depends upon what we're doing in terms of what we want to return. So anyway, I just wanted to give you some concluding comments on that as well. And I'm looking at the time, and we're around 11:30. We have any other special requests for any topics that you guys want to hear more about in terms of the lecture portion of this weekend? You can always think about it as well. Let me know. I'm going to stop this video.